The moon rotates, but you can never see its other side, and the reason is written in the laws of gravity itself. Look up at the moon tonight. Then look again tomorrow, next week, next year. You will always see the same face, the same craters, the same dark patches, the same familiar expression staring back at Earth. For almost all of human history, nobody on this planet had ever seen the other side. It was not until October 1959, when the Soviet probe Luna 3 sent back the first blurry photographs, that humans finally glimpsed the hidden hemisphere. It turns out the moon is rotating. We just never see the other side because Earth's gravity locked it into place billions of years ago. Here's how it works. The moon always shows us the same face, but this is not because it sits frozen in space. It is actually spinning on its axis. The trick is that it spins at exactly the right speed to keep one hemisphere permanently pointed at Earth. For thousands of years, every human who ever looked up saw only that one side. The ancient Greeks, the Egyptians, the Maya, Galileo with his first telescope in 1609, all of them were looking at the same 50% of the moon. The other half was a complete mystery until 1959, when Luna 3 became the first spacecraft to photograph it. Humans had mapped continents, crossed oceans, and climbed mountains long before they ever saw half of their nearest neighbor in space. The effect is called tidal locking, and it is the result of a slow gravitational tug of war. The moon rotates once on its axis every 27.3 days, which is exactly the same time it takes to orbit Earth. This is called synchronous rotation, and it is not a coincidence. Billions of years ago, the moon spun much faster, but Earth's gravity pulled on the moon's shape, raising tidal bulges in its rocky crust. As the moon rotated, these bulges created friction that slowly bled away its spin energy. Over hundreds of millions of years, the moon's rotation was dragged into perfect sync with its orbit. Once locked, it stayed locked. The same process is happening right now to Earth itself, but on a much longer timescale. The far side of the moon is often called the dark side, but that name is completely wrong. The far side is not dark. It receives just as much sunlight as the near side. When the moon is new from our perspective, meaning the side facing Earth is in shadow, the far side is actually fully lit by the sun. The two hemispheres take turns in daylight on a 29-day cycle, just like the near side that we see. The only thing the far side never gets is a view of Earth. To anyone standing on it, our planet would be permanently below the horizon. The name dark side came from the idea of unknown and hidden, not from a lack of sunlight. Astronomers prefer to call it the far side because that is what it actually is. When Luna 3 sent back those first photographs, scientists were shocked. The far side looked nothing like the face we know. The near side is covered with huge dark plains called mare, which are ancient lava flows from volcanic eruptions. The far side has almost none of these. Instead, it is a battered landscape of bright, heavily cratered highlands. The crust on the far side is also much thicker, about 50 kilometers compared to roughly 30 kilometers on the near side. The leading theory is that early in the moon's history, Earth's heat kept the near side warmer, allowing lava to break through and flood the lowlands. The far side cooled faster and stayed rigid. In January 2019, China's Chang'e 4 became the first spacecraft ever to land on the far side and send back images from the surface. If this changed how you see the moon, subscribe to Curious Science. Next up, why do planes stay in the air? The answer is stranger than you think.